I am Colin McKenzie. I graduated from Virginia Tech in 1983 with a civil engineering degree, but I had a specialty in structures. I've been practicing almost 40 years now, and I'm registered in Maryland, Virginia, and DC. I consider myself a friend to Mac ASHI, and I've known Hollis for a while, and a couple of others of you and some other home inspectors that refer me quite often. And so I'm always happy to come and speak before you guys. So while you're thinking of your burning structural questions, the first thing I wanted to talk about was Amsterdam. So has anybody been to Amsterdam? All right, so for me, there's a lot of great things about Amsterdam and Europe. My wife and I went and visited, my daughter lives in Belgium, in Antwerp, Belgium. And so one of our day trips was to go to Amsterdam. And so there's a lot of great things in Amsterdam, the canals and the architecture and the art and everything. But being a structural engineer, I couldn't get past the leaning houses in Amsterdam. And so while I'm talking, I didn't know that I would have access to actually have a PowerPoint. So I am going to pass around. So if you want to just flip through some of these pictures, there's 6 pictures in here of two of the houses that I took. This was one that was near our hotel that was just so badly leaning. It was shocking to me, and shocking with what we typically consider a huge problem around here. But if you want to pass that around, you can. So you can flip through. HDMI port on there? This does not have HDMI. Yeah. So, yeah. Okay. So the thing that really struck me was that there was just go ahead.
One of the things I don't know if you realize is they were built that way. Mm-hmm. They were built to lean because they had to crane all the goods up to the top floor. Right. So they leaned forward so that the goods didn't hit the side of the house. Right.
That's the other thing. So let me talk about that first. So most of the houses in Amsterdam and a lot of places in Europe, the townhouses have a cantilevered beam up at the gable, and it cantilevers out, and there's a hook on the end, and or an eyelet, and that's for lifting things up through the building because the building doesn't have stairways or elevators that can, accommodate that. So everything has to be lifted up. And actually, for my daughter, when she moved into her apartment in Antwerp, they were on the 4th floor, and a very narrow staircase about 2'6" wide, and there was just no way that they got furniture up there. So in Europe, they have a business where there's actually lifts where they set it up on the sidewalk and put all the furniture on lifts, and they lift it up, and they make, her unit had just been renovated, so they make all the windows removable, and so you pop out a window and bring the furniture in that way. So it's a great idea. So in Amsterdam, what they say is that they built them out of plumb and leaning forward so that when you hiked up things like furniture or whatever up the front, it didn't hit the front of the building. And and that's, you knew that, and I had heard that, and I was told that on our boat ride and all sorts of things, and I don't buy it. So one of the reasons I don't buy it is, in general, people just, even back then, these buildings were built in the 1600s and 1700s. They just didn't build stuff out of plumb, and it just doesn't make sense. And I don't know how many times, I would say certainly hundreds of times, when I'm inspecting something that has a big skew or slope or leaning, that somebody has told me that it was built that way, or somebody said it was built that way, or it hasn't moved in 20 years, so it was built that way. So I've just heard it was built that way for so long, and I have never, anything that's skewed or really bad that, supposed to be a legitimate structure, I've not found to be built leaning for that purpose. And then the other part to it is, if you're looking at some of my pictures, is that the buildings are not only leaning forward, they're leaning sideways. And it's usually the end units are leaning, or it's a whole number of units. And the picture I have there, I think that building was an end unit. Then there's another one that is two buildings. Yeah, that one. And then there's another one where there's two buildings, and if you look between the two, there's a V-shaped piece of black, on that picture, of black that's probably, by the time you get up to the roof, it's probably 18 inches wide. And so all they did was, cosmetically, cover over the gap in between the buildings, but the buildings still move that much. And so they're leaning and they're failing, and I would consider them failing because generally of rotting piles. So everything built in Amsterdam was built on wood piles, but back then there was a lot of things that could happen with doing wood piles. Either the piles weren't big enough, they weren't put in deep enough. And so supposedly there's, I haven't studied this in detail, but there's a sand layer, lens of soil that's about 35 feet in the ground. And so the piles were supposed to be driven into this initial sand layer. And even if they were driven into that sand layer, I mean, that's fine. But because of fluctuating water levels, over time, the tops of the piles could become exposed to the air and rot. So that's really what's happening to a lot of them. And then the end units are rotting because, or the end units are leaning because they don't have any support from other buildings. But as you can see from some of the pictures, and if you really look at things online, I mean, what I have there is not an isolated thing. I just took a picture of something that was near my hotel that was very, very badly leaning. So I've always had this saying about doing inspections. And so things like sagging floors and foundation settlement in anything that is, and you can take this to the bank, anything less than 100 years old, badly sagging floors, settlement, big cracks, that's a structural problem. That's a structural defect. But as soon as you get to 100 or greater, that's charm. So there's no, if you have bad things happening to your house, you want to make sure that it's, you hopefully get past 100 years so it goes into the charm category. And so I'm just kind of kidding about that, but it's really, I found, it's kind of the idea in people's minds. So if somebody is buying, I don't know how many, 100, 120, 140-year-old row houses in DC I've inspected, but some of them just have terrible floor sagging problems and leaning stairs and sagging roofs, and but people want them so bad, and they look at it and they just consider that character, or as I said, charm. And so what I realized in Amsterdam is that these houses, I just, being a structural engineer, I just didn't focus on this. They use that and they advertise it, and it's a tourist attraction. So you can have a foundation settlement problem that's actually a tourist attraction. So when you're doing your inspections and you see a bad settlement problem, you can either, if it's less than 100 years old, then certainly it's a structural defect. If it's more than 100, you can, sell it as either charm, or you can sell it as a tourist attraction. So that's, and I don't quite understand how they, in Amsterdam, they're not panicking about some of this stuff, but it's been there for a lot of years. And another saying I have is, if I'm looking at something that's 100 years old, I'm looking at it for, one day, maybe, 1 hour in time. And, who am I to say that this is about to fall down? The building that I have on my iPad is looks like it's about to fall down. And if that was around here, if that building was around here, it would be evacuated and condemned. But it's just it's a nice, I would say, coffee shop, but they're not, they are selling real coffee there. Coffee shops in Amsterdam are not selling coffee. So anyway, so that's my take on Amsterdam. And so I'm so interested now in how they're repairing it, whether they are repairing it. I've done some research, and I think they're from what I can see, I think they're driving push piles probably underneath the buildings. That's probably about the only way, unless you're going to do helical piers, but you're not going to go inside a building and drive a wood pile. So I think that's the method of repairs, and there's companies that are out there doing it, but it just didn't seem like a big deal, and it's actually celebrated. So it's very, very different over there. Yeah, go ahead.
That actually brings up another question that I've got, because we're up in Frederick, and we do a fair amount of the old homes in downtown Frederick. And I've often warned my clients about, they say, well, we've got this cellar and we want to, deepen the floor, we want to finish it, and we want to do all this. And at what point would all of that have an impact on the structure of the house? I mean, they want to turn this uncoursed stone rubble foundation and dry it out because, golly, that cellar is awful damp.
Right. Of course, yeah.
And explaining to them that that's changing the environmental condition of that is going to have a huge impact. Am I sort of over cautious about it, or is this something that they really do need to be thinking about?
Well, I mean, lowering a basement floor has all sorts of issues that have to be dealt with. So I don't do a lot in Frederick, but in DC, an older row house doesn't have real footings. It has usually turned brick footing. So you might get a spread, in an 8-inch wall. You might get an additional spread at the bottom with the turned bricks of, maybe 10 inches or 12 inches, but that's about it. And then the turned bricks are usually right below whatever the, cellar floor is now. So let's just say you had, a 6-foot cellar and you wanted a real 8-foot ceiling. So you're going to go down 2 feet. With those foundations, you're definitely going to have to underpin the footing. So you have to do a full underpin. Of course, the other parts, demo the slab, dig it out, put a new slab in, put drainage in. There's a whole issue with drainage. Especially if you, are looking at a house like you described, with an old rubble stone foundation, those are always going to leak. And then, you could think about a lot of things with the drainage, but, what I've done in the past with old rubble foundations that aren't looking good, and then maybe somebody wants to dig it out, we've done underpinning if that's necessary, but we've also, thank you. We've also encapsulated the wall with a concrete buttress wall in front, and I do it with to make it easy and not have to make that wall a cantilevered retaining wall or try to tie it in. At the top, I do a steel beam, vertical steel beam system. Usually 6-inch steel beams at 4 or 5 feet on center, just like if you were going to brace a bad masonry wall, but then infill that with concrete and then also put drainage board back behind, in between the concrete and the stone, and then get that directed down into, and in the scenario of a new floor slab and a lower floor, it's definitely going to have a new interior drain system and sump pump and all of that. So get that directed in there. So, it can be done, but it's, super expensive, and sometimes it shouldn't be done. And talking about, footing level, there's a lot of waterproofing companies that are out there that will come in and bang in a drain system, but they don't care about where the footing level is. And so if the footing is just below the floor slab and they're going to dig a 12-inch trench or deeper for a French drain inside, they're undermining the footing. And so I've seen it several times, or maybe even many times, where that trench allows the footing to settle because it's not laterally, the dirt is not laterally supported right underneath the footing. And the worst case I saw was up in Dundalk, I think Dundalk. So it was near the water and it was very sandy soil. And so that really screwed things up when they excavated. And so this waterproofing company that I was actually working for, doing structural work that I will not name because they're not that great, or they're actually terrible. They had just put up like a piece of cement board siding up against the dirt and then backfilled with gravel and put the drain tile in. So of course that failed and the foundation started failing in that house. That's another thing. And when I've worked for a number of different waterproofing companies, and one of the things that I keep trying to tell them is, before you even sell a system in an old house, you should be doing a test pit and verifying the elevation of the footing so you know whether you can actually do this. But of course they're trying to make money and sell something, and it's a commissioned salesperson, so they're not going to do that. They want to make the sale. So I mean, those are the two big things about that, lowering the slab, and then also, even if you don't lower the slab, can you get a French drain system in a basement that has leakage but has a shallow footing? And sometimes, I mean, I've specified underpinning just to put a French drain system in because that's the right thing to do. You get a lot of pushback from that, but otherwise, you have unrestrained soil right underneath the footing. All right. Anybody else? I got a question. Yeah, go ahead.
Can you hear me? Yep.
Yeah.
Okay. So in terms of the DC row houses, I've seen many of them gutted where it's 3 stories. They're going to go to the 4th story, taking out the basement, doing all the types of repair that you pointed out, and then they come back in and they'll do ledger boards bolted into the existing brick walls, and then they run floor joists from left to right. Your thoughts on that design? And the brick wall that's anchoring it is really what I want to know about.
Right. Yeah, I mean, you could also say the same thing about a lot of construction work is taking out the rear wall of row houses and putting an addition on and having that lateral stability taken away. Yeah, I mean, back a long time ago, and I don't even know if this is a long time ago, but 20 or 30 years ago, DC didn't really regulate the construction. And so there was a number of row houses that, collapsed because people would renovate them and not provide any kind of support. But they were probably pretty dilapidated to begin with. There's, a couple of thoughts about reframing for row house gut jobs. And so the 3 things you can do is you can try to repocket things back in the walls. You can do what you described, which is a ledger board bolted into the wall, and then you hang the joists on the ledger board. Or you can try to build a 2x4 or 2x6 stud wall next to the brick, and you can try to support the floor that way. Building the ledger wall is particularly popular because that's so easy. So you can just build, it seems like it's easy, but the problem with that is you're transferring all the load down, not on top of the foundation walls anymore, and not on top of let's just say they're both party walls, not on top of the party walls anymore, and you're putting that load down on the floor slab, which in a DC row house is going to be a lot of times 1.5 inch rat slab and just not worth anything to support loads. And so in order to do, the 2x4 or 2x6 stud wall, you need to provide new footings inside the existing walls in order to support that. And so all of a sudden that method becomes a lot more difficult. So the default method that I see most of the time is the ledger. So the ledger board idea is, I think it can be fine, but there's, a couple of things that are issues with that. One is, in an old brick structure, you're trying to attach a ledger board to old brick. And then some people are still in the mindset that even if we're going to do that, we're going to use expansion anchors. So if you use an expansion anchor, that's not going to work because that's going to expand the brick and just pop it. So it has to be an epoxy anchor, but you're still anchoring into old brick, or even worse probably is, old mortar that's just has a high sand content. So I usually won't specify that, because I don't know how many times where, even in a limited basis, I've tried to do that. And then when it's getting built, the contractor says, these walls are crap, we can't do this. If I can, I try to go back and pocket into the walls. And again, that's not very popular. And then one of the other things that with pocketing is that you're either going to go back and you're going to pocket in and you're going to do all new framing with, you're going to do what I'm describing as a gut job. So you're going to do all new framing, but are you going to go back in and do pressure treated framing in order to pocket the joists into the walls? Or are you going to, and there's issues with that and shrinkage of the pressure treated wood, or are you going to try to pocket regular wood into masonry, which you can't do? So I typically specify regular wood, and then I pocket it, and I specify wrapping with a waterproof membrane, self-stick adhesive waterproof membrane, or something that protects it from moisture. So that's what I like to do. And again, it's not always possible. It's, the spacing isn't always where you want it. 16 inches on center, you're going to get 19, 18, 14 inches on center. So builders don't like to do that, and I can understand that. But just the last renovation job I did downtown, we repocketed things back in, and the builder actually liked that. So, and I try to, if I can, I try to work with, of course I'm going to have this designed, but if there's issues in the field, I'm going to try to work with a builder and even possibly change up, how I thought it should be done if there's, problems in the field. I guess the other issue, or the main issue you're talking about with what you had said is, just when the whole building is gutted and the lateral stability or just the general stability of the building. And there's buildings that shouldn't have any disturbance because they're so weak, they're going to have issues. And then there's buildings that, have kind of stood this test of time, and they've done that without specific mechanical anchorage for the floor joist in the pockets in the walls. So if the building is stable to begin with, and it's a fairly, regular rectangular building, then, you can go ahead and take out the joists and redo it without having to do this whole big bracing system. Now, when the buildings get larger, or some of the big houses like in Calorama or some other big buildings, you're not going to do that. And so you're going to have to build, a tower of temporary shoring in order to shore it. But, nowadays there's a lot of row houses that are getting gutted and completely gutted and then built back up, and they're fine as long as they didn't have a serious instability to begin with. Yeah.
If you don't mind, I'll continue.
No, go ahead.
Is there any common tenet foundations or footers with the structures within the DC townhouses or row houses? So it would appear, because they're so tight together, and oftentimes it seems, to your point, the party wall, is there a situation where that footer is actually supporting both neighbor A and neighbor B?
Yeah, most of the time, yeah.
It is.
Unless it's even if it's an end unit, of course, the outside wall isn't, but if it's any party wall is going to support joists coming in from both sides.
Okay.
Yeah. Right, yeah. Well, hopefully you can't see across between the two, but you might be able to. And that's the thing. In a party wall, the property line runs right down the middle, and so except for underpinning, which allows you to go across that party line in order to do it right for those walls, you have basically 4 inches, maybe 4.5, 5 inches in order to work with. And I was just doing another row house where I was working for a neighbor of somebody who's going to gut their house, and they had me review the drawings. I do this a lot because neighbors, when they hear about construction and get the neighbor to neighbor form, they're just panicking. They're like, I'm supposed to give them permission and I have no idea what I'm giving my neighbor permission to do. And so I'll come in and review the drawings and look at their house, maybe look at the neighbor's house if I can get access, and then just provide a consultation on really what they're doing. Are they digging out the foundation? Are they doing underpinning? Are they things that are, higher risk. But in this case, the design included a steel beam that was transferring a lot of loads, just a huge amount of load. I didn't do a calculation, but this engineer who did the design took a steel beam and just was bearing it on the brick party wall, 4 inches. And I would say just, at the top of my head that it was probably 20,000 pound reaction for that beam. And it was on a 4-inch, old brick wall. Now this was like a 1930s building in Burleith, but it's still, and the brick is a lot better there, but, and certainly in a 1930s building. But I thought that was not good. So that was one of the things that I lobbied for, was to get something else done. I wouldn't have done the design that way, but this was done. So we, with some arm twisting, we got the engineer to specify, I think he specified steel bearing plates that gave him, still the 4 inches of bearing in the wall, but it was a 12-inch steel plate. But if I have to do something similar, I really try not to do it, but I will specify a concrete load spreader beam. So I will have a builder take out brick that's maybe 2 feet wide by 8 inches deep underneath where the beam bearing is going to be. And then I'll have them form that up and pour that. And then that provides a good load spreader to spread the load out, let's just say 2 feet over that brick wall. So you're not having the concentrated load just on either the width of the beam that might be, 5.5, 5.25, 6 inches, 8 inches, to something that's more substantial. 12 inches, at least, if you have bearing plates, or I like to go, 2 feet with these load spreader beams. So, those are some of the things that I like to do, because I know from experience that there's going to be issues with old brick. And so I won't push the limit and then say, well, this engineer's response was, well, let's see what happens when they are doing it. And I'm like, there's no control once that happens. So, so we're not going to accept that. Yeah. Well, that was, yeah. So, so that was what happened with that. I don't know if I answered your question about, okay. Yeah, go ahead.
Did this work? Hello? Can you hear me?
I can hear you.
Have you, well, of course. I didn't know. And
I keep forgetting where.
I'm so sorry. Have you designed a repair for like in that picture, like a leaning end unit of a row house? And if so, how much was it leaning and how did you get it?
That's a good question. Yes. I haven't designed a repair for something that severe. And the reason is that I just don't, I don't know what I would do with it, because the foundation can be stabilized, but the building is so eccentric as far as how the load is coming down that, and you're not going to push a building like that back into place. So you have to accept that eccentricity. So when that eccentricity of load and these buildings, like going back to Amsterdam, even in DC, they're 3 stories, maybe pretty much top out at 3 stories, but in Amsterdam and a lot of Europe, it's 4 or 5 story buildings, maybe even 6 story, all brick buildings. So they're super heavy. So I've designed a lot of foundation repairs. And of course, when you're doing foundation repairs and doing stabilization, there is the big burning question for every job like that is, are you going to do a stabilization in place, or are you going to try to, usually we're talking about floor jacking, not trying to get, that kind of leaning out. So are you going to try to get the floors level? And then in that subset of trying to get the floors level, you can try to do a structural leveling where you're actually jacking up floors, or you can do a cosmetic leveling where you're not going to move anything, but you're going to do a cosmetic leveling of taking up the flooring and sistering joists that are flat, or just totally replacing everything if that doesn't work, or if you're doing a huge if you're doing a huge renovation where you're, gutting the whole thing. But yeah, I mean, I don't know what I would do for a building like in that picture. I probably would not want to be involved because I could figure out how to stabilize the foundation, but I don't know, that leaning condition just looks like if something happened, or maybe, another 100 years, that it's just not going to be there. So yeah, I've done a lot of stabilizations, mostly stabilizations in place, because the cost of floor leveling can, double or even triple the cost of a repair, but I've never done something that's leaning quite that much.
You've mentioned older houses a couple of times, and I guess a question is, what is the lifetime of a new house? Because when we're talking about Amsterdam, Frederick, Georgetown, some of those houses are 200, 250 years old.
Mm-hmm.
When I look at modern houses that are made out of sawdust and glue, what are we talking about as a lifetime? 50 years, 60 years, or we don't know?
I don't think we know yet. A modern house, there can be so many problems. I mean, I wouldn't buy a new house personally. So I have a 1954 house. So, and I know what I'm getting. I'm getting a brick and block house, which I'm happy about. I'm getting 2x8 floor joists, which I'm not happy about. So I'm getting a lot of things that I like and things I don't like. But the expectation is you buy a new house, everything's perfect. But nowadays it's, and things just get bigger and bigger. And a lot of times it's a bigger box. So I don't know, something that has, vinyl siding and OSB and just all these things that could go wrong, cheap builder windows. I guess it depends on, what the maintenance level is. But I've seen people, have a new house and they don't do any maintenance for 20 years and it's a piece of crap now. So I guess it really depends, but I would hate to have a client and have them ask me, what is the lifespan? I mean, I would really beg off a question like that. What is the lifespan of this house? Because we really don't know. I mean, I always thought something 100 years old was old, but that's 1923 now. So that's really, in my mind, it's not that old. To me, old is going back to at least the 1800s, late 1800s, and really around here, I think the oldest thing I've inspected was 1749 in Old Town, and that wasn't doing that good. That house, it was an old wood frame house, one of the original structures. So yeah, I mean, new construction, there's a lot to be said that's good about it, but I think durability, it's going to be crap in 60 years, 70 years.
Colin, Scott Morey is describing here in the remote audience, is describing a 3 2x12 beam, laminated beam, where some of the butt joints are not bearing up over the posts, they're out at mid-span. His question is that okay?
Yeah, well, that's another thing. So in the past, I think this is not something somebody would be doing or should be doing currently, but I've seen a lot of beams where they're discontinuous, not at the post, but so let's talk about the 3-ply member. So usually one member is discontinuous at one location, and I guess the rule of thumb for when they were doing this, or for a lot of people, was do it at 1/3 span. So it's either 1/3 or 2/3 of a span. And then the other lap for one of the other pieces is, on the other side of the column at 1/3, and then let's just say the middle piece is lapped somewhere else. All the laps are staggered. So there's supposed to be value in having that, where it's more than just, let's just say 2 of the plies are continuous in one span because the lap in 2 of them are on the other span. So is it technically a 2-ply beam, or is it a 3-ply beam? Because you have that splice. If I'm going to do an analysis, I'm going to say that's a 2-ply beam. I might think about it as there's some value added into staggering the splices, but really that's not okay. And if somebody did that with a modern beam, like if I had a job where I wanted a 3-ply LVL and somebody started staggering and not lapping it over a column, I would be like, that's completely unacceptable. So I would say no. It was done, and you have to realize that it was, I don't know, I use the word acceptable, but I don't, it's acceptable to who. But you see it a lot, and I wouldn't just totally pan it, but another case is there's a lot of 2-ply beams where that happens. So there's only 1 ply that runs through, and you have that splice on one side of the column, and then another splice for the other member on the other side of the column. That beam will typically be working better than if somebody had just come in with a 1-piece 2x12. And so maybe there's some value added, but in a technical sense, if I'm going to do an analysis, that's, in what I just said, that's a 1-ply 2x12, or in the case of what you were describing, if only 2 plies go, if the beam's only continuous with 2 plies, then I only consider it a 2-ply beam.
Would it, can you hear me?
Of course, we'll always have to apply the it's been that way for 40 years rule, and it hasn't moved yet.
Yes, that's, when I was younger, I used to be intimidated by that. I'd be like, I don't know what the hell I'm talking about. And if somebody's has 40 years experience and is telling me that that's the way they've always done it, then gee, who am I to say that it's wrong? But, it's wrong. It's like, 2 2x10s can do anything. And if I put a flitch plate in between it, then I can span it, 40 feet. So there's a lot of misnomers there that, over the years, and now I've been doing this for 40 years, that I'm like, no, that guy was completely wrong. I had this, I'll tell this really quick. So when I was in high school, I was working construction as a laborer, and I was working on the FBI Academy. And so I had to drive from McLean to Woodbridge, or FBI Academy, that's Quantico, every morning in the summer, and get there. I was supposed to get there by 7 o'clock. And of course, in high school, I was, maybe not of course, but I was kind of a partier, and I'd be going out with my friends who didn't have real jobs, and then try to get up at 7 and go down there, and I'd be late. So, and then I would get there, and the superintendent of this construction company, it was a concrete construction company, would always just give me crap and just be like, oh, and I didn't want to hear it, but he gave me crap. And I was always hoping that I could drive the Bobcat, but I was not responsible enough. So he would never let me drive the Bobcat. So I was just a laborer, and that really made me decide that I wanted to be an engineer. So I had, some level of, control. About 10 years later, we designed some buildings up in Flower Hill, and I went out to the job site, and there was a problem. And that guy who was my superintendent and gave me so much crap was the superintendent, and he had screwed up something. And I'm usually not this way, but I was just so happy that he screwed up something, and I could kind of lay into him. And I'm like, this is why I became an engineer. So it's kind of elitist sounding, but it was really good for the soul. So. But now I've come around, and I think I've seen, I always say, I think I've seen everything. Every once in a while, there's something that comes along that is something that's totally screwed up, or, and if somebody, is saying I can do, 2x10s, I'm spanning 2x10s at 16 for 18 feet, but it's only bedroom loading, so it's fine, then I'm just, I know that that's not going to work well, and you're going to, even if that doesn't work by code, but even if it's close to working by code, you're going to have all sorts of other deflection and vibration problems.
I have another question if you'd like.
Yes. Yep.
So concrete balconies on condos, and they're technically built into the brick walls, and it's comprised of what they call 2 Wythe bricks, right? And it sits in there. My question about that design is, does that ever have water penetration such that could deteriorate the interior bonding and concrete at that point, that could make that structurally weak?
No, never.
That's right. Water stays away from situations like that. Right. So you're describing like in an older building, like a concrete, and not a cantilever balcony, right? Like a.
Well, it's
like this right here, it's mounted into this area,
Mm-hmm.
and it would stick out. So it's probably a 10 by 10 balcony.
Mm-hmm. But it's going to have it supported the outside edge, right?
Yes, it is.
Um,
On
and-
3 sides it's supported.
right, right. And then the other side is,
Open to the ground.
well, when you say open, so when you say 3-sided, you mean 3 sides of the building?
Yes, so it would be like this.
Okay. And it would, in order for it to be, so of course if it's a newer building, it's going to be brick veneer, and it's not going to be supported by the brick veneer. If it's an older building that's 2 wides of brick, then they may have done that, in the past. And I mean, structurally, I think that's fine. I don't know how you ever flash and you don't flash anything like that. So it's really just a maintenance issue and a caulking issue. I'm currently working on some 60s apartment buildings in Silver Spring where it has concrete balconies that are on cantilevered steel beams that come out from the structure, but the structure is a wood structure. And so over time, what happened was that, that concrete balcony never had any flashing, and every once in a while, somebody, whoever the owner was, would come along and put some caulk in, but water got back there and it rotted almost all the wood beams over the sliders for the lower level apartment. So, I mean, it does happen, and it happens very easily. And then if you have something vulnerable, like that, like a wood framing, underneath it, it's going to have issues. And these were apartments, so nobody's doing inspections. But if these were condos, it was impossible. I made them tear off all the trim and expose all the beams so we could really see what was going on. And I knew there was going to be issues, but you really couldn't tell without looking at it. And of course, there was pushback. Like we knew there was one bad one because that one had actually failed and the balcony had dropped. But I was like, I think the rest of these are going to have the same problem, and they all did to some degree. So it's not a good design, for waterproofing at all. Yeah. And you might, question whether, if you see any evidence of water getting in, question whether there's, rotting or damage due to that, Yeah, go ahead.
Back to newer buildings, truss roofs. We see an awful lot of missing plates, cracked trusses, cracked members.
Mm-hmm.
A lot of the builders have a comment in their blueprints saying, here are some standard repairs.
Mm-hmm.
But the American Plywood Association and the American Truss Association say there is no such thing as a standard repair. Every repair must be engineered.
Mm-hmm.
What can I say besides providing the APA or the truss manufacturer's sheet that says there is no standard repair, you need an architect or an engineer? What else can I say to get the builder not to use their framing guy to go fix the truss?
Right. Well, yeah. I mean, I see that a lot too. And I see a lot of repairs that aren't adequate. So I would love to say that there's no standard repair, although I use some standard repairs when I specify things, just because I've been down that road so many times and I have a good idea for a typical 28, 30-foot truss that's not, on a monster house that may have a broken member. I pretty much know what I need, what needs to be done. And so for a broken web member or cord member, it needs a 2x4 on each side and then specific nailing, to make that work. And usually you want to go, from panel point to panel point and get a full length member if you can. And then for, either disconnected connection plates or completely broken, there's no reusing the connection plate. So the connection plates are totally worthless once they become detached. And I know that some builders will come and, try to put in a bunch of nails and say that I've fixed that connection plate, but it's, it's toast once it's disconnected. So, so the typical repair is, plywood gussets for a bad connection plate. So you might have all of those things going on. I work with a a large roofing company out of Rockville, and I do most of their investigations for trees falling on roofs where they want their own representation. So we'll have, trusses that are, completely crushed, but we'll usually try to rebuild them versus if it's very widespread, you want to take them out and get new trusses done. But if it's, somewhat isolated, you're going to do that repair. I guess what I would say in that regard is, certainly if it's new construction, the builder should not be using typical details, and they should go back to their truss manufacturer and get a specific detail for that specific condition, because they know all of the loads, and they know all the loads, and they can do the design, and they have for prefabricated trusses, the design is, it seems like it's from, the truss supplier, but it's from an engineer that works for the truss supplier, and usually like MyTech is a big connector supplier. So a lot of times, it comes out of an engineer, a PE that works for MyTech, and he runs the calculations and then produces the shop drawings for the roof trusses. So they have all that information, and it should be a very specific repair for that condition. If it's something older, then you're not necessarily, or you're definitely not going to go back to a truss manufacturer. So there's either getting an engineered repair, and I have some standard details that I know are overkill, and I'll use 16 24-inch gussets on each side in order to bolt it together or screw it together and nail it together. So I know all that works from past experience. And so if you see a splice of a 2x4 on a truss that has 3 nails in it, that was never even remotely engineered. But if it has 2 nails that are spaced at 4 inches on center, then somebody made an attempt to do something that is probably worthwhile, even if you aren't able to get something where somebody says, I had an engineer and here's the engineer's detail. And it's the same thing for gussets. If somebody put a plywood gusset on, or tried to re-nail a metal gusset, then if it's just a 12 by 12 piece of plywood with a couple of nails in it, that nobody really tried and somebody just did a down and dirty repair. So I don't know that I would leave it, that I would say that every truss repair has to have an engineer involved and has to have a specific engineering, but certainly there's a level that you probably recognize as well, that is something that seems good. You can still, of course you have to be technical about it and say, this should have been engineered. I don't know. The homeowner doesn't have any information. The homeowner just bought the house 2 years ago and doesn't have any information for what was done, and this was done beforehand. But rather than just say, if you can't give me that information, you have to redo it or get an engineer involved. I would say there's some discretion in that. Maybe it's not up to you to have that discretion. I get involved in a lot of those, not only for trees falling, but the hallway attic that has 2 trusses cut in order to put it perpendicular to, or parallel to the hallway, but perpendicular to the roof framing. And so there's inevitably with that 2 trusses that are cut. And so with those conditions, I usually recommend, rather than, it's very difficult to transfer all that load around and get that to work technically right. So that's a case that you probably see a lot, and it gets a pass a lot because there might not be any distress associated with it. But technically, those trusses are not, well, I don't want to say not adequate. They're void because they had the bottom cords cut and oftentimes web members. But as soon as you cut anything, they're pretty much void. And then if you have 2 trusses together, you're going to, you have 6 feet of roof, that is going to unsupported.
And we see it a lot from the HVAC guys.
Yeah, right. But
the trusses are gone.
The thing is, and oftentimes it's in a hallway on a house or a townhouse, and there's default support for those roof trusses. So the hallway walls are non-bearing walls because the roof is intended to span the whole way across, but it doesn't fall down because the hallway wall supported, and then so there's this default load path that's not correct, but it makes it so it's not falling down in those cases. So I usually recommend putting those trusses back together and putting a new bottom cord in and splicing it all together with new gussets and new web members and bottom cords, for that. So that those conditions really shouldn't get a pass, and those should have an engineer, specify what the repairs will be, just to make sure it's done right, and then there's resale and all of those things.
Oftentimes, sorry?
Yep, either one, that's fine.
Oftentimes when we see things like that, we do bring up resale. And he said, you may be willing to accept the risk, but when you go to sell, the next person in line might not be so much, and they're going to want it repaired, which is going to be on you. So you can either fix it now, or fix it later.
Right.
And the same thing is when we do get a engineer's letter or something, we say, make lots of copies of it, put a whole mess of them in a baggie and staple it to the repair.
Right. That's a good idea,
Yeah. It's a great idea, because, somebody's going to say, who authorized that? Oh, I need one of these.
Yeah.
That goes in your report.
Boy, I've never seen it, but that would be great.
I've seen it twice in 20 years.
I'm gonna have a plastic baggie and a stapler whenever I'm done. Yeah. Yeah, go ahead.
When the load is transferred to the upper hallway walls, where would the crack be in the first floor when the non-load bearing walls are now load bearing?
I mean, oftentimes you just don't see anything because it's not, for a roof structure, there's no load on it. So in 90% of the time in this area, there's no load on it. So it doesn't, there's no stress, and it doesn't have enough, and it's hard to say. When I was saying hallway walls, it's more of a default thing that keeps it from falling down, but from the top cord where the snow is to transfer down and transfer that load, you would, if you don't have web members that actually came down right on top of the wall, then that's not going to transfer the load properly, and it's not going to, I don't even want to say properly. None of that is proper, but the point was it's not falling down, and oftentimes you don't see any distress. So you're probably not going to see any distress or pick it up from looking for cracks down below. I mean, I've seen a lot of offset bearing walls where it was, I hate to say it, but it was built that way. And that's, I've done a lot of work in Tacoma Park. That's a place that has a lot of issues, I'm sure, as you all know. So foundation issues, floor sagging issues, and a lot of those houses have offset bearing walls. Sometimes, from the first floor, it's offset the bearing wall of the first floor on top of the first floor from where the beam is, or as you go up higher, it might be, sometimes they'll turn around the framing and have bearing walls that are parallel to the floor joists and don't have any provisions for that. But usually for those conditions, and especially, the Tacoma Park issue where it might be, 80 years old, you're going to see the distress from that, because it's not like a roof where 90% of the time you don't have any load, and some winters like we had last year, you never have any load. You have this constant load of an old house with plaster walls that are and load being transferred that's pushing down and causing really bad floor sagging. The Tacoma Park example is a good example, but you just won't see that from that. But if you just see a pull down stairs to an attic and a hall, and which way the roof trusses are spanning, and it's perpendicular to that, that they've cut trusses. And sometimes it looks really great and they framed it out and it looks really pretty, but it's not pretty structurally.
So I want to change the theme here. A number of years ago, Colin's daughter bought a house. What was her name? Shannon?
Shannon,
Stephen Shannon, yeah? Yeah. So Colin called me out to do the inspection, and I got to the garage. I looked at the garage door, and I explained that I'm not going to test the garage door. And the agent said, well, why not? And I said, well, because it's not safe. And he says, there's nothing wrong with that garage door. And he went over and pushed the button and the door opened. I turned and walked away. I wouldn't have anything to do with it. I don't even want to be in the garage when he pushes the button again. He pushed the button again and the door closed. And he found me, he looks me up and he says, see, there's nothing wrong with that garage door. 2 weeks later, Colin sends me this picture. He said, this is the very next time they opened that garage door after they bought the house. They bought the house, and when they went to move in, they opened that garage door, and that's what happened. I don't remember.
It was an old metal door that this house was it was in Linden, if you all know where that is, and it was up on Apple Mountain Estates, it's actually coming around. You know, it used to kind of be a vacation type area, but it's coming around for permanent residences. And this was supposedly just a terrible house that was a bank repo, and they've actually fixed it up pretty nicely, but they had a deck on the back that was all rotted, and this garage door that I had asked, Hollis had said, you know, after the inspection we were talking, he's like, this garage door is not going to last any more than a couple of weeks. And I didn't even really think about it. And so when my son-in-law sent me the picture of the collapsed garage door, I was like, damn, Hollis is good. He knew it. So they replaced it with an insulated door. So they were very happy, but they've since sold that house and they bought a house in Fairfax City. So they're only 5 minutes away from us, which is great for us and seeing the grandkids. And so now they have another house with a bad wood garage door. So I'm trying to get them, and somebody had took the eyes and took the wires off and wrapped them around up there. And I'm like, you know, you need to replace this. And so I even offered to pay for their garage door, but there's only so much you can do as a father or father-in-law.
There you go. So anyway, Colin McKenzie.
Thank you.